Good morning, students. Today we are going to discuss very important topic that is called as laser. So, what do you mean by laser, and how do we can use it, and what are the applications of the laser? So, basically, laser is the name of laser has been abbreviated as light amplification amplification by stimulated emission of stimulated emission of radiation. So that means, it is basically light which has been amplified by the process stimulated emission. So that is why it is called as a laser. Now, why do laser differ from the light? Now, what is difference between the laser and the ordinary light? Ordinary light, we know that when you put the laser inside any room, you find out a simple spot dot will be formed on the wall. But as soon as you switch on a bulb on that, so that light will be get spreaded out over the whole region, wherever the bulb has been placed out in the whole region. So that means there are certain properties which are possessed by laser which make it differ from the ordinary light. So laser has some special properties. One of the important property is that it is monochromatic. Monochromatic. Second, it is coherent. Second, it is coherent. Then third, it is very intense. Intense. Fourth, it is have high energy. Fifth, its focusing point. And sixth, its directionality. So these are the 6 properties which are being possessed by the laser which make it different from the ordinary source of light. Now, what do you mean by monochromaticity? What do you mean by coherence? So let us discuss all this by detail. Now, monochromatic. Monochromatic, what does it mean by it? By monochromatic means the light should be of single frequency. So since whatever the normal source of light we are going to take, its emit pulse like this way, means wide range of frequencies are being emitted out. But although it may be of same color, let us say it is a sodium lamp, it emit yellow colors, but yellow colors, they are again divided up of different frequency, yellow 1, yellow 2, all these things are there. So that means there is no purity of the signal is there, and frequencies are spread up into particular region. So that width to be source to be monochromatic, this width should be, pulse width should be minimum. Although there is nothing is an ideal source which is monochromatic, laser has monochromaticity extremely high. That is, the width of them between them is very small. So due to very small width, very a single unique frequencies or difference in the frequencies are very small, or the frequency range is very small. So due to that, the laser has been used as highly energetic source. Second property which has been possessed by it is coherence. Now, what do you mean by coherence? Coherence means all the particles which are being coming out, which should be move with phase or non-phase with each other. So this is a source of light which are being overlapping over each other, and so this is a non-coherent source. And in coherent source, all the particles emitting from the different phase, they should come out with the same phase and move in the same direction. So this is a coherent. So coherent means all the particles should move in same phase, and non-coherent moves, they should move in a different phase. So ordinary light is a highly non-coherent source, while laser is a highly coherent source. So that due to the coherence, due to monochromaticity, the laser is being different from the ordinary source of light. Then due to these properties, the other properties are being possessed. So due to monochromaticity is very high intense, and due to that intense, it has got high energy, and due to high energy, so due to the coherence, it can focus at very small point, focused at very small point, and all, then it has, once it gets focused, it has got a particular directionality. So all these properties which are being possessed by the laser, which make it different from the ordinary source of light. Now let us explain about the details of laser. Now we have discussed that laser is light amplification by stimulated emission. Now light has to be amplified. What do you mean by amplification? For example, any signal which passes through certain region, it get enlarged. So that is called as amplification. Amplification. So that is the process of amplification. Then stimulated emission. So that process you have to understand. Stimulated emission. Now to understand this stimulated emission, um, we have to understand about the three different processes: spontaneous absorption, spontaneous emission, and then the stimulated emission. Spontaneous emission, and then the third is stimulated emission. Stimulated emission. So what happens in spontaneous absorption? We know that there are two different states are there. One is called as the ground state and excited state. Most of the atoms are there in the ground state. Let us say very few are there in the excited state. Now we have to make them to get the atom to be emit radiation. We have to excite them from ground state to the excited state. They cannot go by itself, but we have to provide some energy from the external source. Let us say this is the incident photon which strike to the material, and then the material gain energy and goes to the excited state. But there is a condition that this photon should have the energy difference greater than the energy difference of these two. So if the energy difference is smaller, then the photons, the atoms will not go to the excited state, they will fall back. So this process is called as a spontaneous absorption. So spontaneous absorption depends upon the incident photon and the number of atoms in the ground state. So any one of the state is absent, so then there will be no absorption process will takes place. Now then once they got absorbed to the excited state, these two states are there. Ground state is called as very stable state, and another excited state is called as unstable state. Unstable state means the atoms cannot remain stable in the excited state. So this is your ground state, this is your excited state. So once the atoms go to the excited state, they cannot longer remain there in the excited state. So what happens? They automatically come back to the ground state and emit radiation. Now automatically means they have some lifetime that is of the order of 10 raised to minus 8 second. So after 10 raised to minus 8 second, the atoms come back by emission of radiation in the random direction. Because according to Bohr, when the electrons jump from higher to lower energy level, they emit radiation but in random direction. But once the atoms emit radiation in random direction, so we can never obtain a coherent beam. So that means spontaneous emission, again with the help of spontaneous emission we cannot obtain the laser beam. Now the third process is being there, that is called as a stimulated emission. Now in stimulated emission, what we need is, let us say this is the ground state, this is the excited state. We allow the photon to fall. Now what happens? There exists one more stable state. One other state is called as a metastable state. Now this state arises because of certain reason, and once the atoms gain energy, they go to the excited state. So some of the atoms, they come back by itself to the ground state, but some of them, they go to the trapped inside this state. Now this state exists very close to the excited state, having lifetime of 10 raised to minus 3 second. Upper state has lifetime of 10 raised to minus 8 second. So now this lifetime is much larger than the lifetime of this one. So this will stay there for a longer duration. Now once they stay here, they cannot come back and cannot emit radiation until unless we force them to bring them. So what we do, we fall some photon to pass through it, incident photon again to pass through it. What they cause? They cause the perturbation of the atoms in the metastable state and causes the atoms to come back to the ground state. Some of the energy is being used to perturbation, the rest of the energy for emission of the photon, and second, once the atom come back, so that will again release some energy. So one photon will cause emission of two radiations. Now how two radiations are being emitted? One is the partial amount of energy of this photon, another is for energy emitted by the atoms by the de-excitation of two. So these two photons, further they can cause further de-excitation of another two photons, two atoms, and so once they get de-excited, so they emit four radiations. So this is how the multiplication of the process of photons takes place. And this process of multiplication is called as a photon laser amplification. So that is a phenomena of light. This is process is called as a stimulated emission, and this process is responsible for the laser action to takes place. So stimulated emission is the main process which is being there, and without a stimulated emission no laser action takes place. Now then the process problem arises, what are the components required to make the laser? So these are the processes which are involved in the laser. What are the components required to make the laser? Component required. So one of the component required is, one is called as a pump, and second is called as a medium, and third is called as a resonator. These are the major component, and other component which is secondary part which is required only in certain laser, that is called as a coolant. So these are the four components which are being required: pump, medium, resonator and coolant. Just like we have a pen, why I want to make a pen, so what I need is this body of the pen, refill, and then the ink of the pen. All these components are being required. Once these components are being with me, I can fabricate any kind of pen with it. So similarly, without these components no laser can be created. So in the next lecture we will discuss how the laser can be made by using these components, and then what are various kind of lasers and where we can able to use it out.